will be introduced during the sequel, like on the first slide. Um, I will do this first presentation. I don't know very well how to gather the right information that may introduce myself, my team, and the fields on which we work actually, usually, and how this all can fit within the framework of the project that we are currently working on, which is Let's Say. I'm gonna try to do it as best as possible. So currently I'm the head of the Lebanese Center for Pedagogical Innovation at AUL. I will introduce it in the next slide. I'm also a part-time lecturer at the National Lebanese University. And here are some links to my list of courses on my private Moodle website and my YouTube channel, on which I record a couple of courses like this one, actually, like this presentation. I upload everything on it. So very quickly, I will introduce myself and the center. Then I will talk about AI and automated reasoning, which is the main focus of my research interest. And then I will talk about my experience in software engineering, which may also help in this project, as I hope eventually. About a virtual reality project that we worked on for 3 years with a Ph.D. student of mine, and then what I'm expecting for our serious games project. So I started like Ahmad and many of the students of Mrs. Ghada as a geek, even like 3 years before the joining the university. So I started my BS in computer science, but actually it was like the first year was in math and physics. Then we switched like really after 3 years to computer science. It was a bit harsh for me, but also this also shaped my profile so that I could candidate to more theoretical fields such as artificial intelligence and automated reasoning. I started my master degree in France, and then I completed my PhD in AI, specifically in logic. Not only classical logic, but various format of logics, as I will show you in a few minutes. Afterwards, I worked for a software engineering company. I shall talk about it later on. For a couple of years. It was very interesting. And then I rejoined the academia once again in Lebanon since 2012, where I'm actually doing a lot of stuffs. I'm teaching different courses, a lot of courses actually currently, supervising a few master's theses and senior projects since then, and doing as much as I can beside that extracurriculum activities, namely the a deep project during which I met Mrs. Ghada, and I established the robotics lab and the virtual reality lab at AUL. Not only buying the equipment, acquiring the equipment, but also training the colleagues and the students on them, and getting them involved in competitions, national competitions, to encourage them to use these technology. So the LCPI that I'm currently working on, very quickly, it shall offer AUL guidance towards excellence in higher education through continuous improvement of their program, the review of the program, their adequacy to the job market, especially in our fields of information technology, where everything is really going very fast. But even in the other fields, and to try to integrate technology and innovation as much as possible in our curriculum design. So not only the tools such as recording the courses like I'm doing now, but also to use these tools wisely to get better versions of the curriculum and its delivery, both of them. So we shall develop, orient, accompany, and measure the progress of both the students and instructors. So we have a committee called Teaching and Learning Committee, and the head of the LCPI is the responsible of this committee. And we take care of allocating the right human resources and equipment to make this whole process a success at the end. So we refer to the president of the university. We work closely with the faculties and the quality assurance department and the information and communication technology department. Okay. So getting back to the three different titles. So we start with AI and automated reasoning. This is from my PhD thesis defense. You have the slides and the thesis available online on this link. So for the extra slides to which I'm gonna switch right now, I'm gonna make a quick glimpse actually to these slides. The complete introduction will be during the course of Mrs. Ghada on Wednesday. But just to give you an idea about how we can use mathematical formalism such as graph rewriting or logic to model systems and to reason about them, okay? So it happens that whenever you have an idea, a plan, let's say an itinerary, to go from one place to another, or whatever other idea or model in hand, you start, like as a human in general, we start drawing bubbles and linking them with arrows, so what we call a graph. And actually, it's a very strong formalism that allows you to represent and to reason about a lot of different cases. So just to draw your attention to the power of these formalism, imagine that you have a very basic system, such as a switch bulb system. So you can represent it as a graph by thinking about its two states, possible states. So usually the system is either in the state where the lights are off or the state where the light is on. And you can use arrows to say that by performing the action toggle, you can go from one state to another. Okay? It's quite straightforward, it's quite intuitive, it's quite simple. But what if you have actually a mouse in the system? So I'm gonna jump till here. What if you have a switch bulb mouse system? So here, maybe you can make your system a bit more complex and express the fact that when the light is off, by toggling the switch, you may reach two possible states. Either the light will remain off or the light will be switched on. And actually, this means a lot because you will say that after toggling the light, the switch, it's not necessarily that the light will be on, okay? Like a few minutes ago, we had this necessity. This is like this absolute truth. And now we don't have something that will be absolutely true, okay? So we have this plausibility or possibility. So actually, it is possible that it's not the case that the light is on, okay? Because light off is not light on. It's a different state. And we usually express it like this, like it's possible that the light will be off. And this actually cannot be captured by the classical logic where you only have true and false, okay? So you need some extension of this truth idea. And this is fantastic, actually. So I did my whole studies just to better understand this idea. So this was the course that captured my attention, because once I traveled and to another country and I saw that they are doing things in a completely different way, and it's working, okay? They have different cultures, different ideas, different ways of doing things, and it actually works. So as if a truth is a relative thing, and this is really wonderful. Actually, modal logics and all their formats and extensions are these formalism that allow you to reason about plausibility, possibility, and the granulation of the truth. So they use two different symbols called the box and the diamond, or the necessity and the possibility, to express the fact that a certain proposition or logical proposition is absolutely true, or a certain proposition is possibly true. And their eternal question is how to evaluate these formulas. Actually, I'm going to get back a little bit to show you that it's not only about such systems. We can also, where we have actions, for example. Here we were modeling the result of a certain action, how it will change a certain system property, okay? But we can actually use the same formalism to express other more interesting concepts, such as knowledge and belief representation. So here, for example, Alice believes or maybe knows that the card is the ace, the hard ace. But Bob actually does not have any knowledge about the card that it is on its head or his head. So to capture this, we can use once again a graph and say that the card is either black or red. Alice has a complete knowledge about it, and also a knowledge about the current actual state, okay? But Bob thinks that it is either red or black, okay? And that Alice knows the truth, okay? It will take a little bit of time to convince you that this graph really represents the other fact, but it will be our work during the session with Mrs. Ghada. Maybe a more basic system, the traffic light system. Here we have what we call a transition system, okay? That goes like automatically over time, such as an automated system, a metro system that governs itself without the intervention of a human. So unlike the switch bulb system, it goes indefinitely from the state red to green to yellow and so on and so forth. But it's maybe the time that govern this concept. So actually, modal logics have been extended to express temporal aspects, and this led to what we call temporal logics. They are used to express knowledge, what we call cognitive logics, okay, to model knowledge and beliefs. They have been extended to represent deontic logics. So you can represent all the laws of a certain country or subset of it at least, and start reasoning about it and check whether there is one law that contradicts another one, or if the some institution will propose a new regulation that will violate one of the existing rules, and so on and so forth. So we have all these powerful systems to represent real world and to think about it. So very quickly, how we usually do it, we talk about the concept of possible words, okay? So there is no only one possible word as we know it currently. There are plenty of possible words. So it is possible to, like for instance, in Lebanon, usually when we shake hands with someone else, we give them 3 kisses, while here it seems it's only 2 kisses. So in another possible word, like things can be different actually. And this can be absolutely captured by graphs like these, okay? I will leave the details for the course. Usually we can write very complex formulas and think about how to verify these formulas within these graphs. Very simple example, we can say that in a certain model, it means a graph, at a certain specific word, it means at a specific node, if we have the fact that A and B are true, then at that specific word, A should be true and B should be true. It's very, very intuitive. And we can reason like this. As for the modal operators, in which we capture the notions of absolutely true or necessarily true or possibly true. So when in a certain word we can pretend that A is absolutely true, this means that in every single possible word that is accessible through a certain relation or through possible arrows from W, A should be absolutely true in A. And for possibility, it is sufficient to find that in one possible word, A is true. So given this fact, we can now express things and verify them. And we actually, during my PhD thesis, I was interested in verifying the formulas and working on this, because it all starts with philosophers. They think about a new concept. What does it mean, obligations? What does it mean, permissions in laws? What does it mean to know something? What does it mean to believe something? What does it mean to regret something? Like even emotions, they represent them with rational actions. I regret something because I had a plan or a strategy to realize it, but I didn't follow that strategy. I actually did something else. And you feel it actually quite reasonable. You can discuss it as much as you want with philosophers, and you will find different schools. But once the philosophers fix the definition of a certain concept and its consequences, you can try to represent it using modal logics. And then what you can do actually is very interesting. I'm going to jump to that slide. You can start thinking about verifying systems, properties of systems. So imagine that you have a system S, for example, the legal system in Egypt, or in a specific institution, to make it simpler, or an automated metro system, okay? And you have a set of properties that you want to check whether S have or has that set of properties, yes or no. For example, does the property safety hold in a certain automated metro system for passengers? So all that you have to do is to represent the whole system as a set of formulas that describe the functioning of the system and the desired properties, safety or whatever, or security, with a set of formulas. You put them together and you check up whether the system has these properties, yes or not. And this is actually brilliant, because if you have only two different laws, you can check them very easily on a piece of paper. But when you have a complete constitution, okay, or a very complex system with hundreds of thousands of possible states, okay, so you won't be able to do it exhaustively on paper. And here comes the role of automated reasoning, okay? Another interesting problem that we have in real time, given a set of property, is there a system S that may fulfill these properties? So can I build a system that can acquire these properties? And a third problem, given a set of properties, which system among several different ones that you have already may fulfill these properties? Actually, why we are they seem for the first sight quite similar, and actually they are, but technically they require different automated reasoning approaches. So the first one is called modal checking. You draw the graph, okay? You put everything you know about the possible words in the graph, and then you put a certain initial formula describing the system, and you start evolving the resolution of that formula and checking whether it holds yes or not. The second one is called satisfiability. You have a formula, and you want to check, is there any possible model or a graph that fulfill that formula? So actually, to do this, it's sufficient to create only one model, okay, or only one graph. But the last approach is, on which I worked during my PhD thesis, is to do a complete model construction and to also analyze why you couldn't, for example, build a certain pre-model or model for a certain formula. Why you couldn't satisfy such a formula? It will track back the inconsistency in the formula to tell you that the problem comes from these two subsets of flows. Actually, you have to either remove this one or that one. Okay, I'm gonna stop at this stage. I know that you want maybe to know more about it, and I will switch back to my original slides. So to let you know what I actually did. So of course this field is very active and we have a lot of research in it. There are plenty of different logics, as I told you, with different semantics, deontic logic, cognitive logics, temporal logics, and so on. So we have different expressivity and hence different complexities, okay, in terms of computation. To verify a certain formula, whatever will happen in the future, there is a specific moment after which, whatever you do, there will always be one single moment in the future where you can have this or that. This is like a very complex thing to verify and to draw out all the possibilities. It gives you an explosion, an exponential explosion in complexity. Okay, so maybe you already learned data structures and algorithm complexity, so you have an idea about this. And actually, it happens that for certain formulas, we need the age of the universe, or maybe hundreds of times the age of the universe to verify them. So you don't have the time, like you need to verify your airplane system before delivering it to the market. So you need a feasible solution. And here it comes the whole field of automated proofs methods and automated reasoning. There are many approaches out there, and but only few tools, unfortunately. So what I wanted to do is to create a tool that is user-friendly and that has an acceptable performance, and that allow the end users who are researchers or students in logic or philosophy and who are not hence computer science experts to use my tool in a very user-friendly way to define their own new logic with which they prototype, okay? And to check the properties of these logics before adding this axiom or after adding this axiom, before removing this rule or after removing this rule. So I created a tool called BlotTrack that takes in a logic definition in terms of a graph rewriting rules, okay? And whatever input formula or model or whatever, and then it will generate set of graphs that actually represent for the researcher or the student a set of extensible models where the properties or systems are coherent, or to non-extensible models where the systems are incoherent. So it has like this interface. I couldn't simplify it more than that because like the problems usually they are complex, but actually the end user has only to spot a certain blue node somewhere when there is a clash, and if everything is blank, then it means everything is fine and the formula is satisfiable. Of course, for a certain formula, there are plenty of possibilities, and they come from the fact that you have disjunctions, okay? Because imagine that in the morning, I always drink coffee, but I may wear this shirt or the other one. So it means in the morning, only for this proposition, I have two alternative words where I can drink my coffee and have this sweater, or drink my coffee and have the other one, okay? So, but imagine in real systems, okay, the projector is either on or off, is on VGA port or HDMI port, and so on and so forth, okay? So you have plenty of disjunctions, and this creates a lot of branching, and this is why we have this interface. It is accessible from this website, and of course, anyone who wants to know more about it, either on Wednesday, I can also give you the sources. This led to several publications, even one recently where we enhanced a little bit the performance of the tool. But the biggest pride for us is this book, which we call the Kripke's Words. Kripke is a German researcher who first talked about this mechanism and about modal logics. So in which we have exercises that can be done with the accompanying tool, with Lautrec. I'm very proud of it because once, like at the beginning, I liked the very basic idea of possibility and necessity. I knew that it's very promising, but I couldn't easily get on board, because we have a lot of very complex mathematical formalism, and I really wanted, by the end of my thesis, to make this accessible to all the students working in this field around the world. And I hope that we successfully did it in 2013. Afterwards, I moved to something completely different. For a couple of years, I worked in a company called Genigraph. Today, it's called Soft Team, something like that. It's between Paris, Toulouse, and Tunisia. So we worked on an e-governance platform, I'm going to say, not a website or a web page or whatever. It's really a platform where it is also generic. Like this joins this is the only point in common, abstraction. I like abstractions, okay? So once you know to do this, so you can make an abstraction to do a lot of hundreds of very similar things. So what we used to do is to allow the end users, who are themselves developers, to define using UML-like formalism their logic and their software, their data, and the processes being handled with these data. Let's say you want to ask for a certain visa, okay? So you have to present certain documents, but then you have to wait. And then there is another agent from the back office who will handle this request. And they will ask another higher position employee to amend or accept or reject this demand, and so on and so forth. So you have your original request, and it will be processed over time. It will change over time. You have plenty of formalism, such as BPMN, business process modeling notation, that govern or allow you to show how data changes over time while defining all the permissions of all the actors at the same time. So I hope maybe you already learned about it in your software engineering course. So we allowed the end user to define UML-like diagrams and to define BPMN-like diagrams. And they have a couple of combo boxes where they can choose the type of the database that they want, the type of the server, okay? Not the type of the language, because we did everything with Java, but as simple as that, the number of nodes on which they wanted to deploy their web application, and then boom, we generated everything for them. The processes will be translated into a set of steps. The steps are physical web pages. They have next button and back button to complete their procedures, and yes, and they and we had actually very serious clients like the state of Luxembourg, So we had to work really on harsh deadlines and to deliver safe, secure software with high quality standards. The state of Panama and, of course, many regions in France. The software actually win plenty of prizes all around the world. So just to give them the credit, they started on it 2004. I joined them in 2010. And one of the things that I worked on was actually this clusterization of the deployment, okay? Because it was not an easy task. It required a lot of distributed and parallel computing tweaking actually, because you have like, it's not an easy task to manage locks and synchronization when you have plenty of different nodes, but yet one single database, okay? So we worked on very interesting topics, and we had a quality assurance department. So we really absolutely applied all software engineering concepts. I like to add this slide just for the students, for them to know that UML is not just a fancy way of saying things, and you have to learn it just to pass the software engineering course. No, actually in real and large scale software, we really use it. Unless they had written all these specifications and design documents, I couldn't join them very easily within 3 months to understand all that they have done since 2004 till 2010. And of course, after I left them after 2 years, the next developers who joined the team, they couldn't actually understand what I did unless I documented every single thing in these documents, okay? So here you have a video that shows really how professionally the document was made, with exact dates, the name of the responsible persons, the name of the version that we will, where this will be shipped. Everything is documented, every single action and decision. Even the commands, we leave them there to say that actually, yes, we did this compromise just because the client needs it, but in 2 versions we are going to do this or that. So every single decision is documented within these documents, and this is really great. Where did you? Oui. Ah, le GUI sketches, I think, or something like that. Patterns, GUI patterns, or I think they mean sketches. Okay, so what I really gained actually as an experience, and this is an advice for all of you, sometimes we really like to do geek things, to work like Ahmed is really willing to do directly in a software engineering company, to join them, to work with them. So 2 advices. First, be wise while choosing your side. Don't choose very small companies where everything is done in a hassle, without quality assurance and without deep thinking before going to the market. And second, actually, never believe that stopping your studies at the BS level and joining the software engineering companies is a good thing, because after my PhD, so after 5 years, when I started the first task, instead of directly implementing the first task that they assigned to me, I spent maybe 3 out of the 5 days that were assigned for designing, for implementing the task, on reading related works. Okay, so once you start, once you get used to reading what the others have done so far on whatever domain, you will actually have this critical thinking that prevents you from doing anything without a valid reason for it. Okay, و خلاص ما حدش يقدر عليك بعد كده. Okay, so after maybe 3 months or 4 months, I shifted my work from a software developer to a software architect very quickly, because they needed me in the meetings and in the reflections and so on. So the critical thinking that you gain from the academia is really precious. Okay, so keep this balance, and you will be of course, learn about the new trends and technologies to not be left behind, but keep up with the pace. But also the theoretical foundation are really required for the everyday life, actually. The shift to virtual reality. I still have 10 minutes, 5 minutes. Okay. Okay. the shift to virtual reality happened with a PhD student who is at the same time a colleague at AUL. His name is also Bilal. He started his PhD on virtual reality with the ENIB from France. It's in Brest. And he worked on very interesting
We will start to prepare the reactives.
topics. Actually, there they have a platform.
Open the tube of
This is really
neoplastine.
interesting for you, Ghadam, for
Why?
the project, actually. So they worked on,
pour
first of all,
solvent
what's
inside.
virtual reality? Just quickly.
Why?
It's
In order for the reagents to be used,
usually a 3D environment. It's a virtual environment that reflects the reality. It should reflect the reality of with all its details, with all its possible states and the properties. So hence the points in common with my original
Neoplastine is product for blood analysis.
For me, it's not interesting the graphics of this airplane ship.
this is solvent and
It's
not
rather the set
neoplastine.
of objects interacting together.
Where
Their
is
properties
neoplastine?
and their behavior, what they can do when you
It is
click
here.
on them, or when you launch them, when you do this and do that, and how you can capture this with a
This is neoplastine, but you have to open.
manner. So usually they use virtual reality systems to do
Open the tube of
to
solvent.
create complex learning environments where the
We
end
will
users
start to
should
prepare
have
the
hands-on
reactives.
exercises, yet the
Open the
environment
tube
is
of
very dangerous.
neoplastine.
So, for example, instead
Why?
of training your soldiers on real
To pour
terrorists,
solvent
it's
inside.
better to have it in a
Why?
simulated environment. Okay? Or, for example,
In order for the
instead of
reagents
gathering
to be
hundreds
used,
of employees in a ship and dedicate 3 or 4 hours to train one pilot, okay? So creating this virtual environment and allowing the pilots to
Neoplastine is product for blood analysis.
hundreds of times without costing fuel or whatever, without risking their lives. And
this
the
is
lives of
solvent
others
and not
would be really great.
neoplastine.
Okay, there are plenty of other
Where is
applications in
neoplastine?
healthcare, surgeries, in
It is
firefighting,
here.
and so on. So the aim of Bilal was to actually develop or
This is
actually
neoplastine, but you have to
to
open.
integrate what we call embodied conversational agents in these environments, because these
Open the
agents,
tube
even
of
if you get
solvent.
close to them and you start discussing with them, or
We will start
waving
to
or doing
prepare the
whatever,
reactives.
you want, they will always be waving with their
Open the tube of
flags. So
neoplastine.
it will not give you
Why?
a human credible interaction. Okay.
To pour
So,
solvent inside.
What it
Why?
is really desired in such
In order
virtual
for the
environment is
reagents to be used.
reflect the reality also with the trainers themselves, the virtual agents or the virtual trainers. Here we talk about what we call intelligent tutoring systems, not just tutoring systems or simulation systems.
Neoplastine is product
in
for
which
blood
you have,
analysis.
pedagogical scenarios implemented, not only automated interactions between the objects.
This is
but to
solvent
have
and
a
not
plan for this.
neoplastine.
And this comes from the world of education.
Where is
from all the
neoplastine?
research on how to
It is here.
train certain learners on a certain concept and how to assess them on it, and so on and so
This
forth.
is neoplastine,
And once they
but you
this
have to
model,
open.
They can define it with, in their work actually, they could define it on a UML-like structure within an abstract tool called Masquerade. And this is another point in common. This is why I really like the project called Masquerade, okay? It was developed with the main supervisor of Bilal Nakhal, called Ronan Kerek from ENIB Brest, and during his PhD thesis, but then they did a lot of subsequent work on it. So Bilal wanted to add this. Yes. At least we can make a collaboration with Ronan. We can contact him and check it. To a large extent, yes. What you need usually, just to give you a better idea, you need to pay a certain graphic design company to draw you the scene. But it's up to you to define with Modal, which is a UML editor, to define all your scenarios, pedagogical scenarios, in terms of like a pedagogical scenario has several different actors implied in it, and they can make certain actions on the objects. And what Bilal wanted to do actually is to add certain speech recognition module, because it wasn't done earlier.
Sorry about that.
Yes.
Interrupt once again.
Go ahead.
Would this resolve in part the question that we were asking yesterday? Because
It may actually. It may.
It may contribute to giving us an environment to work on.
Yes, it may.
Okay.
And this is why I really want to also.
Thing and have the mascara thing.
Masquerade, yes.
Mascara,
Yes. Masquerade, the framework. Like you take like Masquerade takes in an XML XMI file that is exported from UML diagrams, and it will generate all the logic of the environment, okay, for you. But to actually embed these interactions within a physical system, it requires a Unity 3D environment that is already designed by a graphic designer. With all the properties matching the definition given by the UML diagram, and then the Unity engine will take this definition from Masquerade and will function magically.
You know what, Dr. Bilal? I think
Yes.
One important output or decision is that you make available, maybe today and tomorrow we've got, tomorrow and after tomorrow we've got planned activities to work on.
Yeah.
But I think as soon as we get back to Lebanon, you have to make available a learning environment online for the team. So that
You mean?
so they can test it. A learning environment, a tutorial on this online through your modal, bilalsaid.com or through wherever. You can share it
Yes.
through our Moodle, our platform that will be open to
Just to be clear on it, I didn't closely work on Masquerade. Like I often join them during all their most of their meetings, and I helped with this part actually a little bit, which formalism can be used to add the intelligent part to the agents. So this was like, since I worked on automated reasoning, so I had an input on this point. But the technical part about how to define a certain scenario, absolutely, I saw it several times being done under C# and Unity and so on, and being defined in Modelio. They change just a couple of arrows in a certain UML diagrams, and then when you click on this button, the scenario will change. Okay, so it's magical, it's good, it's working, but I don't know the exact technical details about how it's working. I should refer to Bilal Nakhal when we get back, and to see in which way he can be involved with us, if we can also benefit from his experience in this domain. And I'm quite sure he will give it a thought, but I'm not sure. Yeah. I put all these on purpose just to show that there are such they exist. We can collaborate directly with Renaud or with Bilal. We can see what we can do. Akid, if Bilal can collaborate with us, this would be great, and he's with us at the same institution.
Yeah, I think working on their deliverables and the output of their previous projects will, ça va mettre en valeur ce travail.
Absolutely.
It will add value to what
Sure.
they have done, and they should be happy about it.
Sure. What you see here is actually this scenario that has been accomplished by the end of his PhD thesis. So the scene has been already prepared. This actor, I think this one is Mark. It is a predefined embedded conversational agent. So a company drew the character, but all the definition files, they can be used by the others, and you have just to give them orders to say, like, wave, explain, do this, do that, and there is predefined languages to do this, such as the functional markup language. Like, after you take the right decision, you generate this FML and you give it to the embodied conversational agent, and magically this will give the right interaction. Okay, but everything else is also controlled by Masquerade. It allows you to define a knowledge base, a set of agents who are the human beings, and virtual agents who represent these embodied conversation agent, and to define all the interactions between them. So yes, there are plenty of recipes, ready recipes. Masquerade is one of the possible solutions out there. Okay, so absolutely a credible possible partner. So this brings me to the last point. Serious games for students' orientations. Actually, this just kicked off. I already love it, and I hope this will benefit our students and all of us, our institutions. And this that this will be a success for everyone. And I hope to see you all of you soon, once again. Is it fine? Am I on time?
Thank you very much.
Thank you. Thank you.
Allow me to pose some questions. Sometimes I feel my students have questions in head. Maybe they didn't formulate.
Yeah.